Shut up and sit down.
Hi, I'm PJ McTavish. Welcome back to another D.C.G tutorial. So this one we're doing the prospective question from the 2017 paper, which was B-3. A question that was requested like most of them. So to quickly read through it, so the figure B3 shows a plan elevation for a display box similar to one shown in the image on the right. The design is based on a regular hexagonal prism which is truncated as shown. A pictorial view of the box is also shown. So A, we have to draw a given plan and make a perspective drawing of the box given the following. The spectator point S is 1 meter from the surface B as shown. The picture plane PP contains vertical surface B as shown. The horizon line is 1.2 meters above the ground line, and then the sloping lines of surface B and C are inclined at an angle of 15 degrees to the horizontal plane. So use an auxiliary vanishing point to determine the sloping line of surface C in the perspective drawing. Then we have to do a development. So looking at that straight away, so first of all there's a scale 1 is to 10, just be aware of that. Everything has to be divided by 10, and it says start off with the plan. Now I've set up my page in portrait because some of these perspective questions end up off the sheet if they're in landscape. So I'm going to start, now our spectator is directly below, so I'm going to start in the middle here. So at the top of the page in the middle I'm going to do the plan. So we have a regular hexagon and it's 0.4 of a meter in length of the sides, and with your scale that will be 40 mil. So I'm going to start that up here with my picture plane, and we'll go through setting it up. So we'll draw that in first. Okay, so that is the plan put in with our picture plane and also the spectator, which you were shown in the plan. It is 20 mil in here. It's halfway between the base here, and the spectator said in the question, in the right hand section, it told you the spectator is 1 meter away from surface B. So that was your 100 mil. Okay, so our picture plane is there, and then our horizon line is 1.2 meters above the ground line. So let's start putting in our ground line horizon line now first. So in order to figure out what angle we're going to be projecting at, we must join the furthermost corner to the left and to the right back to the spectator. So we're going to join this point and that point back to the spectator and bisect that angle to figure out what angle we are projecting at. It looks like it's going to be actually just vertical, but let's bisect it just to be on the safe side. So our projection angle is going to be a vertical angle. Let's set up our vanishing points now. So get the vanishing points. So what we do is we use the external angles of the object and project them from our spectator in order to find a vanishing point on the picture plane. So in this case they're both 60 degree angles. So draw 60 degrees from your spectator to the left and to the right. That's giving you VP1 and VP2. We just need to project them down to our horizon line and ground line. So this is actually going to be handy enough one with our projection angle being vertical. So for some of it now you might not see the top of the... I just adjusted the height there of the camera just so you can see the full page. So for our horizon line, doesn't matter where you put that in, so I'm just going to put it as close as I can to the spectator to make sure I have loads of room. And it said it was 1.2 meters away from the ground line, so that means we're going 120 mil away or down for the ground line. Okay, that's our horizon line, that's our ground line. So now what I'm going to do is project down VP1 and VP2 to find them on our horizon lines. Now what tends to happen with these questions is you normally have a point. You only have a straight line on your picture plane. We'll be going across like so. But in this case we have the full surface B here is on your picture plane. So that full surface is going to be a true shape. It's not going to be projected back to any of the vanishing points. It's not going to be in perspective. It's going to be a true shape. So we can, they're already on the picture plane. We don't need to join back to the spectator. So we can bring those points straight down to the ground line and measure up our 90 mil of a height to find the surface B. So I'm going to do that first. So bring these 2 points straight down and put in your height from the ground line. So that is surface B put in. Next what we're going to do is we're going to do the two side surfaces. We do A and C. So this is A, you're going to be on the right hand side, B in the middle there, and then C to the left. So what we need to do is join the back corner here of surface A back to the spectator, which is already done for you. Where it crosses the picture plane, project that straight down. And what we're going to do is join the top and bottom of our right hand side here of B back to VP2 to figure out where it ends. Okay, so let's bring this line down straight first. So it's already crossed the picture plane, so project that straight down. Let's do the same with the left hand side. So just marking in the corners of the surface there. So this was A, this is B, and that is C. Now, even in this question now, as we look at the left hand side, almost giving you the solution as well to what it's going to look like in perspective, giving you the 3D of it. So now we have to finish off that hexagon at the top. So what we need to do is any horizontal line, because it would have been horizontal in the elevation, needs to be projected back to its vanishing point. So this point here, I'm going to vanish back to the right hand side. That point vanish back to the left hand side. So we don't have these 2 points are for the front. So for those 2 back points, so these 2 points here need to be joined back to the spectator. See where they cross the picture plane and project that straight down to our perspective. Then when we bring these 2 points across, it will show us where it ends. So that is the top of the hexagon put in now. I'm going to just join that across lightly, should be a straight line. Now for the next part of it is the top section. So we have a height of 40 mil at the top, which is going up from here, and we have to put that in. Now to find that 40 mil height, we can't just put it in here straight at the back because we're vanishing back. You even see the distance here, that's 40 has now been reduced to this size here. But on the picture plane, on this front surface here, that surface B was a true surface, true shape. So if I mark the original 40, the true height 40 here, and I project it back to VP1, if I project it back to the left hand side, where it crosses the left hand side, that should give you the height in perspective, because you're projecting it back to VP1. That's the angle it's sloping back at. So what we were doing is putting the full height, the true height, on the true shape here, the true surface there, which was 40, join it back to VP1, and where it crosses this vertical line here, that's your height, draw it across, and then we can finish off the top section of it. And with that done, we're drawing in strong, and we'll focus on doing the lines on the surfaces then. Now, the last part of A there, it says use auxiliary vanishing point to determine the sloping line of surface C, which is in the perspective drawn. So it says that your lines here, so this one is up 0.15 of a meter, and it's a horizontal line. So on surface A, it's simple enough. If it's horizontal, it must be drawn back to VP2, that's its angle. On surface B, it's a true surface, true shape, so we can just draw back at 15 degrees. And then for part C, or surface C, we need to draw back at an angle, or use an auxiliary vanishing point for surface C. So let's see, it will be going over here, and it will be going up at a height. So we need to mark our auxiliary vanishing point above VP1. So aux1 will be above, aux vanishing point will be above VP1 here. So we're going to work off VP1. So VP1 back to the spectator. Our angle of our auxiliary vanishing point is 15 degrees. So I'm going to go 15 degrees off VP1. I'm going to draw a line perpendicular to that new line from VP1, and that will give me a height out here. That height, I mark it above VP1, it'll give me my auxiliary vanishing point. So I'm going to go through that for now. Okay, so just in the build up there, I said that you went perpendicular from the 15 degree line, but it's actually you go perpendicular from VP1 in order to find a height here. So this blue height here, this blue line, that is your auxiliary vanishing point 1. That's the height you put above VP1 in order to figure out where it's vanishing to. So now let's focus back down here. The height is 1.5 meters above the ground line. On surface B, it's a true shape, so we'll just put in our 0.15 meters, which is 15 mil. No, A is horizontal, so let's join that back to VP2. From here, it is a true shape, so we're going to go 15 degrees. Still need to get a new protractor. That's where it was across surface B. This is now going at your vanishing point OX1, OX VP1. So that is the angle back there. So now we can draw that in strong. Okay, so that is the perspective question done. So that is part A done. Now part B, it says, on a separate diagram, draw a one-piece surface development of surfaces A, B, and C, and include the lines on surface A, B, and C in the development. So we're going to do development of it. So what I'm going to do on the separate diagram, your B here is a true shape. We've already put in our height. So instead of going off and doing another bit, I'm just going to project over here to the right hand side, just far enough away that it'll stay away from the perspective. So I'm projecting the height over here to the right hand side. I'm just going to zoom in on this because I'm going to focus on B now. So the shape is based on a regular hexagonal prism, so all 6 surfaces, A, B, and C, or all the 3 surfaces will be the same. And we have the true shape here, so we brought out the height. The length is 40, so this is A, B, and C. Now the measurement we were given for the lines is that the height up here is 15 mil. Now we can actually project across this height here from the perspective, because that's a true height. And we know that on A it's horizontal. On B, starting here, goes up 15 degrees. And it says that 15 degrees is the horizontal plane. So if you start here, it will continue on. So the 15 degrees will continue across. It's going to be a straight line there. Because it's angled at 15 degrees, oriented 15 degrees to the horizontal plane. So it's not like it's 15 degrees to itself again here. So if I get 15 degrees again here, 15 degrees to the horizontal plane, or the XY line if you're drawing orthographic views. So therefore this is the line on both surfaces B and C. You continue on that 15 degrees. This is 15 degrees inside here. Okay, and then we'll draw that in strong. So because of the surface development, don't forget your fold lines in between the 2 surfaces. And then that is our lines on surfaces B and C just inclined at 15 degrees to the horizontal. So that's part B finished. Now I hope the orientation of the page comes out okay on this video, and that you can actually see the lines, etc. But it wasn't too complicated a perspective question compared to other years that or other perspective questions that have come up in past years. So as always, I hope these tutorials help. If they do, please leave a like, and don't forget to subscribe so you know when I upload. So thanks for watching, and we'll see you in the next one.